Section 7.8 is about polynomial inequalities and also about rational inequalities. There are two objectives. Number one is to solve quadratic inequalities and other polynomial inequalities. And then the B part is about solving rational inequalities. So we begin with a very simple example, and that's we solve the quadratic inequality x squared plus 2x minus 3 greater than 0 by graphing. So and the way we do it is we create a table of values to graph the function f of x equals x squared plus 2x minus 3. We begin by writing this as f of x equals x squared plus 2x minus 3. And here's the table of values for some selected x values, and then we compute the corresponding functional values. So we have about 6 ordered pairs, which we're going to plot on this coordinate system. So from looking at the graph, we notice that for x values greater than 1, the function is greater than 0. And when x is less than negative 3, the function is also greater than 0. And between minus 3 and 1, the function is less than 0. So therefore, the solution would be the set of all x such that x is less than negative 3 or x is greater than 1. And in interval notation, the solution set would be from minus infinity to negative 3, union from 1 to positive infinity. These are the values for x for which this is true. This is the solution set for this statement. The next example is similar. We begin by writing this as f of x equals x squared plus 2x minus 3. And then we graph that particular parabola. And from comparing it with the previous exercise, we notice it's the same parabola. So let's just graph that. So here we notice that for x values between minus 3 and 1, the function is negative. So therefore, the solution set is a set of all x such that x is less than 1 and greater than negative 3. And in interval notation would be minus 3, 1. So here are the steps to solve a polynomial inequality. Get 0 on one side, set the expression on the other side equal to 0, and solve to find the x-intercepts. Use the numbers found in step 1 to divide the number line into intervals. Substitute a number from each interval into the related function. If the function value is positive, then the expression will be positive for all numbers in the interval. If the function value is negative, then the expression will be negative for all numbers in the interval. Then select the intervals for which the inequality is satisfied and write set builder notation or interval notation for the solution set. So let's do this with the following exercise. Solve 5x times x plus 1 times x minus 1 greater than 0. For this exercise, we set the expression 5x times x plus 1 times x minus 1 equal to 0. And using the zero product property, we set each factor equal to 0. So 5x equals 0, so x equals 0. Or x plus 1 equals 0. So it means x equals minus 1. And then the third factor, x minus 1 equals 0, so x equals 1. Let's draw a number line and mark these points on the number line. Let us select a point in each interval, and this one, and the one here, and here, and there. So let's start with minus 2, so x equals minus 2. That gives us 5 times minus 2 times minus 2 plus 1 times minus 2 minus 1, and that's equal to minus 10 times minus 1 times minus 3, and that is minus times the minus to the plus times the minus to the minus, that's less than 0. So in this interval from minus 1, it's negative. Let's select a point in the second interval. Let's say x equals minus 1/2. That gives us 5 times minus 1/2 times minus 1/2 plus 1 times minus 1/2 minus 1. So it will be minus 5/2 times 1/2 times minus 3/2. The minus times the minus is a plus, so it's a positive in this interval. And let's select a point in the interval 0 to 1. So let's say x equals 1/2. That gives us 5 times 1/2 times x equals 1/2 plus 1 times 1/2 minus 1. So that's 5/2 times 3/2 times minus 1/2, and that's less than 0, so the function is negative in this interval here. And then let's select a point to the right of 1, greater than 1, like 2, x equals 2. So we have 5 times 2 times 2 plus 1 times 2 minus 1, which is 10 times 3 times 1, and that is greater than 0. So the function is positive in this interval. So then the solution set is as follows. It's a set of all x such that x is between minus 1 and 0, or x is greater than 1. And in set builder notation, it would be the interval from minus 1 to 0 union the interval from 1 to positive infinity. So I wrote the solutions next to the original problem statement, and here's a derivation of the solution. The next section is about rational inequalities, and the way we solve a rational inequality is as follows. We change the inequality symbol to an equal sign and solve the related equation. find the numbers for which any denominator in the inequality is not defined, and then use the numbers found in steps 1 and 2 to divide the number line into intervals, and then substitute a number from each interval into the inequality. If the number is the solution, then the interval to which it belongs is part of the solution set. Then last, select the intervals for which the inequality is satisfied, and write set builder notation or interval notation for the solution set. Let's do this for the following rational inequality: x plus 1 divided by x minus 2 greater than or equal to 3. Step 1 was to make this an equal sign, so we have x plus 1 divided by x minus 2 equals 0, and the denominator is not defined for x equals 2, so the inequality is not defined for x equals 2, not defined for x equals 2. That should be a 3, of course. So now when we solve this equation, we multiply both sides by x minus 2 to clear the denominator. So we get x plus 1 equals 3 times x minus 2. So x plus 1 equals 3x minus 6, or 2x equals 7, or x equals 7 divided by 2. So let's graph the number line and mark the points on the number line. So here are the important points: 2 and 7/2. Now let's select a point to the left of 2, like 1. So let x equal 1. And let's substitute that into the original inequality. So we get x plus 1 would be 1 plus 1 divided by 1 minus 2, which is 2 divided by negative 1 greater than or equal to 3. That is false. Now let's select a point in the interval from 2 to 7/2, 7/2 rather. So let's say 3. X equals 3. Then we get 3 plus 1 divided by 3 minus 2 is equal to 4 divided by 1, or 4, and that is greater than or equal to 3, so that is true. So this interval is, for that interval, the inequality is true. And then just to check it out, see what happens when x equals 4. So when x equals 4, then from the original inequality we get 4 plus 1 divided by 4 minus 2, which would be 5 divided by 2 greater than or equal to 3, and that is false. So then we are limited to this interval here. And so the solution set is the set of all x such that x is greater than 2 and less than or equal to 7/2, or the interval from 2 to 7/2. That is the solution set to the rational inequality.
We first of all make this an rational equation, x divided by x minus 5 equals 2. And we notice that the expression is undefined for x equals 5, so that's one point. Then we solve this equation, so x equals 2 times x minus 5, or x equals 10. So that's the other point. Let's draw the number line. So let's find out for which interval this is a true statement, or which intervals. So first of all, let's select a point to the left of 5, for example 0. So let's select x equals 0. Then our inequality x divided by x minus 5 less than 2 becomes 0 divided by 0 minus 5, which is 0. That's less than 2, so that is a true statement. Next, we select a point in the interval between 5 and 10. Let's say 6, x equals 6. So this would then be 6 divided by 6 minus 5, which is 6 divided by 1, less than 2, that is false. So that's for the interval between 5 and 10. And let's select a point that's greater than 10. Let's say 11, x equals 11. Then we have 11 divided by 11 minus 5, which would be 11 divided by 6, less than 2, and that is true. Therefore, the interval from to the left of 5 and to the right of 10 are the intervals for which
this rational inequality is a solution. So in other words, the set of all x such that x is less than 5 or x is greater than 10. And if we do it in interval notation, it would be from minus infinity to 5 union the interval from 10 to positive infinity. So here I've written the solution set next to problem number 7 and also next to problem number 8, and then the derivation of the solution set for number 8 is on the page here. The next exercise is about the height of a thrown object. The function h of t equals minus 16t squared plus 32t plus 1920 gives the height h of an object thrown from a cliff 1,920 feet high after time t seconds. So that is a function that defines the height. A. For what times is the height greater than 1,920 feet? And for what times is the height less than 640 feet? Let's draw a little picture here, a little graph to visualize what's happening here. So here's the cliff, 1,920 feet high. And so let this be the origin. And so the object gets thrown into the air, it goes up, eventually it goes in a downward path. So the time is here on this axis, and this would be h of t as a function of time. So basically the question is, when does the object reach the level of 1,920 feet? For which time? So what we do is we therefore say, okay, minus 16t squared plus 32t plus 1,920, for which values of t is that greater than 1,920. So again, we make that an equation. So minus 16t squared plus 32t plus 1,920 equals 1,920. So then the 1,920 cancel, and we have minus 16t squared plus 32t equals 0. And we can factor a minus 16t out of this expression. That gives us a t minus 2 equals 0. And we have two solutions. We set minus 16t equal to 0. So t equals 0. Or t minus 2 is equal to 0. Or t equals 2 seconds, of course. So since t equals 0 simply means that's the starting point, this is the time when we reach this point here. And so therefore, the solution would be that the set of all t's such that t is between 2 and 0 seconds. Or in interval notation, between 0 and 2. So that's for the A part. And for the B part, it is similar in that we now say, okay, we want to know when minus 16t squared plus 32t plus 1920 is less than 640 feet. So again, we make that inequality an equation, minus 16t squared plus 32t plus 1920 equals 640. When we subtract 640 on both sides, we get minus 16t squared plus 32t plus 1280 equals 0. We can factor out a 16, or minus 16. That gives us a t squared minus 2t minus 80 equals 0. So here we have the product of two factors equal to 0, minus 16 times the expression in parentheses. And since minus 16 cannot be 0, it must be true that t squared minus 2t minus 80 is equal to 0. So this we can factor into t minus 10 times t plus 8 equals 0. And setting each factor equal to 0, t minus 10 equals 0, or t plus 8 equals 0. And this will give us t equals 10 seconds. And this is t equals minus 8 seconds. The second solution does not apply here because time cannot be negative. So this answer tells us that when t is greater than 10, then this condition is satisfied. Then the height will be less than 640 feet. So formally we can say the solution set is a set of all t such that t is greater than 10 seconds, or in interval notation from 10 to infinity. So here's the derivation of part B, and so here is the answer, the solution to part B. And I also wrote the solution next to the original problem statement, and so you've seen the derivation for the A part and for the B part. This concludes section 7.8, and it concludes chapter 7.